Welcome to Unit 6. Before going on to what Unit 6 actually entails, I should probably remind all of you, if you have not already done so, to review the courses that begin in Term 1 on Monday, June 29th, shortly after our class here actually ends. You could go onto the student portal to review your schedule, which you just go to post.edu and click on the student login. You could call and email your academic advisor, your academic success counselor, to make sure that you're on track with graduation. You could check out the virtual bookstore, which if you wanted to do so from Blackboard here, the link to that is right on here, just to see if you need any textbooks, and reach out to your financial aid to ensure that your aid is complete and all documents are received. But with that out of the way, let's move on to Unit 6. This is on correlation, regression, and association. We return to the correlation coefficient in this unit. The last time we saw it was Unit 1. To test how it measures the linearity of the association between variables. Based on this correlation coefficient, we will build linear regression models and multiple regression models. Once we have these models, we can calculate both the predicted values and the prediction intervals for these values. Finally, we can use dummy variables to apply categorical values to regression equations and then apply dummy variables in logistic regression models when it comes to the dummy variable being the response variable as opposed to a predictor variable, which was the first portion of that. The unit then switches to determine how well a distribution fits using a hypothesis test. We can then draw contingency tables to find an association between the two variables. Then we will determine the independence of events. We could use the contingency table to determine if different populations have different proportions, so on and so forth. A couple of objectives that kind of personify this particular unit are to calculate the correlation coefficient for paired data and write formal hypothesis tests about the linear correlation, calculate the least squares regression line of best fit and the multiple regression model of best fit, and interpret the equations when necessary. Predict and interpret values of for the regression line by using a prediction interval, and infer the population regression line with confidence intervals. Apply categorical variables as dummy variables in linear regression and logistic regression, in the terms of predictive variables first and then response variables. Apply normal distributions, hypothesis tests, and goodness of fit tests to contingency tables to determine if the table fits the distribution and to determine independence. In our textbook, this refers to both chapters 10 and 11, so sections 10.1 through 10.6, and then 11.1 and 11.2. I have a whole bunch of optional resources for you to look at, other various textbook resources, and a couple of additional videos aside from these particular ones. The Unit 6 discussion board is on regression analysis, which you can then find in these instructions. Listed down here, we have two tables measuring the pain of intensity before and after using the drug duragasic, which is basically just fentanyl, which is based on data from the Janssen Pharmaceutical Products LP. The data are listed in order by row, and corresponding measures are from the same subject before and after treatment, aka meaning that they are paired or matched data. For example, the first subject had a measure of 1.2 before treatment and a measure of 0.4 after treatment, since these are before and after. Each pair of measurements is from one subject, and the intensity of pain was measured using the standard visual analog score. A higher score corresponds to higher pain intensity. So when it comes to these tables, we would have the first row followed then by the second row, third, and then fourth, in both of them. so that way the data actually stays as paired. But for this discussion board post, using the methods of chapter 10, which again based on that linear regression, which is the best method in order for us to describe this particular data tables? Correlation, regression to independent samples, matched pair samples. Why? Perform this analysis with your answer, and what does it mean? So basically just explaining what you did and why you did it. The peer response requirement is, do you agree with your classmate on his/her choice? Why? Back up your answer, explain yourself, that type of thing. And of course, respond to at least 2 peer posts. I have the data files listed on here as well, if needed, of course. As you can see, we have all 18 of them in there. And then the Unit 6 problem set 6 down here, due by this Sunday of the particular unit. And as you can see, this is out of 84 points, asking a whole bunch of questions involving chapters 10 and 11 from our textbook. As you can see, it asks a whole variety of things. But that is what we are doing here for Unit 6. Let me know if you have any questions or concerns. I'll be happy to help. Thank you.